at some more integration techniques. So the first part is mainly just revision of trigonometry, of techniques that you have done already, and we start with the integrals of trigonometric functions. In the first one, we have x squared sine x to the power of 3 dx. So we want to integrate this. So you can see that if I were to differentiate x to the power of 3, I would get 3x squared. So if I put a 3 over there, then it is exactly the derivative of this. So what I do in integrating is I put a 3 and x squared sine x squared dx. But just putting a 3 there changes the question. So to reverse me putting a 3 there, I have to put a 1 over 3 over there. Okay, so now I can go ahead and integrate this in one step. This is just 1/3. The integral of sine is negative cos. So I have a third negative cos of x to the power of 3, and my constant of integration, which is 1 over 3 cos of x to the power of 3 plus c. 2 the integral of cos 1 over x over x squared dx. So again, here, if I differentiate 1 over x, I would get negative 1 over x squared. But what I have here is positive, so a negative is missing. So I can put a negative here and another negative there so that I don't change the question, but it is in the form that I want it. So this is the integral, negative integral of cos 1 over x over negative x squared dx. And from there, this is just negative. The integral of cos is sine. So I have sine of 1 over x, and then you add your constant of integral. We have the integral of sec squared 5x minus 2 dx. So here the derivative of 5x minus 2 is 5. So I can put a 5 here and a 1 over 5 outside, so the question isn't changed. So I have 1 over 5, the integral of sec squared of 5x minus 2 dx. And now this is in the form that I want it to be in, so I just integrate. So this is 1 over 5. The integral of sec squared is tan. So this is tan of 5x minus 2. Then you add your constant of integration. Or we have the integral of e to the power of x cosec squared 1 minus 2e to the power of x dx. So again, the integral of 1 minus 2 e to the power of x is minus 2 e to the power of x. So we only have e to the power of x, so I need to add a minus 2 here and a minus a half outside. So I have minus a half, the integral of minus 2 e to the power of x cosec squared of 1 minus 2 e to the power of x dx. Okay, and then look at the integral of cosec squared. That is negative cot. So I have yeah.
What if you put 1/2 outside and you
What?
take minus cosec squared and you just put cot?
What if I do what?
Like Miss took -1/2 outside the integral sign, right? Integral.
Yes.
What if you only take 1/2 and then you take -2 minus cosec squared so that you can put cot only?
You can do that.
All right.
Okay, so this is minus a half, and we say the integral of cosec squared is negative cot. So we have negative cot of 1 minus 2 e to the power of x plus our constant, which gives us a half cot of 1 minus 2 e to the power of x plus c. And the next one, number 5. So a lot of these. 5, the integral of x sec x minus 1 times tan of x squared minus 1. Okay, so here our brackets are the same, which is good. And if I differentiate this bracket here, I get 2x, but here I only have x. So I can put a 2 here and then a half outside. So I have a half integral 2x sec of x squared minus 1 tan of x squared minus 1 dx. Forgot the dx here. And then our integral is just half. The integral of sec tan is sec. So I have sec of x squared minus 1 plus the constant of integration. Number 6, we have the integral of 5x cot of 5 to the power of x, not 5x dx. Okay, so here the derivative of 5x is, 5 to the power of x is 5 to the power of x ln of 5. So I have 5 to the power of x, ln of 5 is missing. So I add ln of 5 here and then 1 over ln of 5 outside. So I have 1 over ln of 5 integral of 5 to the power of x ln of 5 cot 5 to the power of x dx. Okay, and this, here we have to use substitution. Somebody saying something, yeah?
I have a question. It's not actually a question. It's like I want to ask how I'm supposed to do like a type of question, but I need to give a question to Miss so that Miss can do it, and I see how Miss is going to do it.
How are you supposed to do what?
Like all the examples Miss is giving us, it's like something we can, like we already have the formula, like cot, we know it's gonna go to minus cosec, and cosec is gonna go to minus cot, like something like this. Now, my question is, what if like they put sec squared x times tan x? How are you supposed to do that?
Well, that depends. Sec squared x tan x, you can write it as sec times sec tan.
And
this is the function, this is the derivative.
all right, Miss, thank you.
Okay, so here, because we don't know the derivative of cot right away, we have to write this in terms of sine and cos. So we have 1 over ln of 5, integral of 5x ln of 5, and then cot, this is cos 5 to the power of x over sine 5 to the power of x dx. Okay, so the derivative of sine 5 to the power of x is cos 5 to the power of x, 5 to the power of x ln of x. Okay, so we have the entire derivative of our denominator there, and now we can just integrate. So this is 1 over ln of 5, and then this, we can look at it as sine of 5 to the power of x of minus 1. So the integral of that is ln of sine 5 to the power of x plus c.
Yep.
Yeah.
Is it needed that you convert cot to cos and sine? Can't you just like integrate and write cosec squared?
Right, cosec squared. Are you saying that
that's that's the derivative, right? Okay.
Okay, I don't understand your question. Okay, let's look at one more. Number 7, we have the integral of cosec ax plus b dx. So here again something is missing, or the derivative of ax plus b is missing. The derivative of ax plus b is just a, so I need an a here and then a 1 over a outside. So I have 1 over a and then the integral of a cosec ax plus b dx. Okay, and then to integrate this one, cosec, the integral of cosec, we multiply by a special term. So this is 1 over a integral of a cosec of ax plus b multiplied by cosec a plus b, ax plus b, and cot ax plus b over cosec ax plus b plus cot ax plus b. So again, this is something we did last semester, so you should remember this, and this is all with respect to x. Okay, so this fraction over here is equal to 1. So if I multiply this by 1, I haven't changed anything. And then if you multiply out, what you get is 1 over a. The integral of cosec, we have a first. We have cosec squared of ax plus b plus cosec cot ax plus b cot ax plus b, and then divided by cosec ax plus b plus cot ax plus b. Okay, and dx must still be there. Okay, then if you look at your denominator, if you were to differentiate the denominator, the only thing that is missing, the only thing that is missing there is the negative. So I can add a negative there and negative there, which I should have added in the beginning. Because the derivative of cosec ax plus b is, did I multiply this out completely? Cosec, yeah, cosec squared. Okay, so the derivative of cosec is cosec cot negative, and the derivative of cot is cosec squared, and this should be negative. So both of these in the numerator will be negative, and you can factor out the negative. Put a negative there, and then obviously you have to multiply each of them by the derivative of your brackets, which is a. So this one is multiplied by a. This one is also multiplied by a, which is factorized out. So here I will put, I don't want to have to rewrite this. So we said a negative is missing, therefore the numerator to be, okay. So now what we have in the numerator is exactly the derivative of what is in the denominator, and then the integral is just ln of your denominator. So this is minus 1 over a ln of cosec ax plus b plus cot ax plus b, and then you add your constant of integration. Okay, so there are numerous exercises in the Technikon book that you should go through. And like I said, most of those techniques used there, whether it's substitution, using the table, we did them all last semester. So it'll take very long for us to go through all of them, so we won't. And now we actually just move to integration of hyperbolic functions. So this is newish, but not that different from what we did last semester. So it's only new because we have just done hyperbolic functions this semester.
Yes,
Look at, yeah, say again. Okay, so we have the integration. I can't hear you, you're breaking up.
Quickly go back to the previous page.
The integration of hyperbolic functions. So you have to keep in mind what hyperbolic functions are. Like hyperbolic sine e to the power of x minus e to the power of minus x over 2, then sine has its own definition and so on. So keep those in mind. So the first one we look at, this is more like a table summarizing. If we have the derivative of f of x and the hyperbolic sine of f of x, and this is what we want to integrate. This, as we know, is just cos hyperbolic of f of x plus c, because the derivative of cos is hyperbolic sine of that function, and then you'll multiply by the derivative of the function. Okay, then number 2, if you have this f prime of x and then hyperbolic cos of f of x plus c. So the idea is the same, is you always want to have the derivative of what you're taking hyperbolic cos of outside, so that you can just write the derivative like that. So the derivative of cos, the hyperbolic cos, is the integral of hyperbolic cos is sine. So this one is positive, they're both positive. And then don't forget your constant of integration.
Yes.
Yeah.
Go back. Why did you put a 3 as number 2?
Why did I do what?
Put a 3.
It should be dx, not a c, sorry. Okay, for number 3, this should be, this one is f prime of x sec hyperbolic squared of f of x dx. So here, this is just hyperbolic tan of f of x plus c. Then when we have f prime of x multiplied by hyperbolic sec of f of x tan hyperbolic of f of x dx, this is just negative sec plus c, and the integral f prime of x, and then we have hyperbolic cosec of f of x, hyperbolic cot of f of x dx. Okay, so here we know the derivative of cosec cot would be cosec, but here it must be negative cosec hyperbolic of f of x plus c, then integral hyperbolic cosec squared of f of x dx. This is negative hyperbolic cot of f of x plus c. Okay, and then if we wanted to integrate hyperbolic tan, you would then change it to hyperbolic sine over cos, like we have been doing so far, and then integrate either using substitution or make sure that the numerator is equal to the derivative of the denominator, and then you get ln. Okay, but that one you can easily work out without any problems. The same thing is true for the hyperbolic cot. You write it in terms of hyperbolic cos over hyperbolic sine, then you can see the numerator is the derivative of the denominator, and then your answer is ln of sine hyperbolic of x plus c. So let's look at some examples where we make use of this. So for the first one, we have the integral of the hyperbolic sine of x over 4 dx. So we look at here, the derivative of x over 4 is 1 over 4. So I need to put 1 over 4 here and a 4 outside. So 4 outside, 1 over 4 here, hyperbolic sine x over 4 dx. And now it's in the form that we want to. So this is just 4. Then the integral of sine hyperbolic is cos hyperbolic of x over 4 plus c. And the next one, sec x squared of 1 minus 2x dx. Okay, the derivative of the inside is negative 2, so I need to put negative 2 there and then negative half outside. So negative half, negative 2, 1 minus 2x dx. Okay, and then now I can integrate. The integral of hyperbolic sec squared is hyperbolic tan. So I have minus a half tan hyperbolic of 1 minus 2x plus c. Integral of x squared sec hyperbolic squared x to the power of 3 dx. Okay, so the derivative of x to the power of 3 is 3x squared. So I need a 3 there and 1 over 3 outside. So 1 over 3, 3x squared, sec hyperbolic squared of x to the power of 3 dx. And then you can just integrate. The integral of cosec hyperbolic squared is minus cot. So I have minus 1 over 3 hyperbolic cot of x to the power of 3. And then you add your constant of integration. Number 4, hyperbolic cot of 3x over 4 dx. So we said when you have a hyperbolic cot, you must rewrite it as hyperbolic cos over hyperbolic sine. So this is cos of 3x over 4 over hyperbolic sine 3x over 4 dx. And look at the denominator. The derivative of the denominator is hyperbolic cos of 3x over 4, and then you would multiply by 3 over 4. So I need a 3 over 4 here and a 4 over 3 outside. So we have a 4 over 3 outside, integral, then 3 over 4 here, hyperbolic cos 3x over 4 sine hyperbolic 3x over 4 dx. And here this is just hyperbolic sine of 3x over 4 to the power of minus 1. So when we integrate to the power of minus 1, we get ln. So we have 4 over 3 ln of our denominator. Okay, so that is the derivative that we get. Okay, then we can look at some of the exercises or the questions in 4.1.6. That's 1.6. Let's look at number 1. Number 1 is definite integral, which we did last semester. So remember, definite integral, you integrate the way you normally do, and then you substitute your limits. So we have the integral from 0 to a of hyperbolic sine of 2x dx. So the derivative of 2x is 2, so I need a 2 there and a half outside. So this is a half integral from 0 to a and 2 sine 2x dx. Okay, so now we can integrate. This is a half. My integral of 2 sine hyperbolic of 2x is just cos hyperbolic of 2x, and you evaluate at 0 and a. So you'll substitute 0 there and a there. Here. This is a half hyperbolic cos of a minus hyperbolic cos of 0. And this is when you need to keep in mind what hyperbolic cos means. Okay. Would it help to rewrite it? No, it doesn't really help to rewrite it. So here you can just write it as a half and hyperbolic cos, sorry, this should be 2a. A 2a. And then hyperbolic cos of 0, that's e to the power of 0 plus e to the power of 0, which is 1 in the numerator, and then divided by 2, which is a half. So this is a half. So this is a half hyperbolic cos of 2a minus 1 over 4. That is your definite integral. Number 3, oh goodness. Okay, number 3, we have the integral of hyperbolic sine of the square root of x over the square root of x dx. So we look at square root of x, its derivative is 1 over 2 square root of 1 over 2 square root of x. The 2 square root of x is in the denominator, so there's a 2 missing here. So I can multiply by a half here and then multiply by a 2 here. So this is 2 integral hyperbolic sine of the square root of x over 2 square root of x dx. Okay, so now we can just integrate the sine hyperbolic, which is hyperbolic cos. So we have 2 hyperbolic cos of the square root of x, and then add your constant of integration. 5, we have sec squared ax plus b dx. Okay, so here the derivative of the inside is a, so we need an a here and a 1 over a outside. So 1 over a sec squared ax plus b dx. So the integral over here, The integral of sec squared is 10. So I have 1 over a, sorry, I'm writing 10 instead of hyperbolic. Okay, the question is still the same, it's just it's hyperbolic sec, not just sec. Okay, so the derivative is a hyperbolic tan of ax plus b, and then we add our constant of integration. And number 7, the integral of x squared cosec hyperbolic squared of 1 minus 3x to the power of 3 dx. Okay, the derivative of the inside is negative 9x squared. So I need a negative 9 here and negative 1 over 9 outside. So negative 1 over 9 integral of negative 9x squared hyperbolic cosec squared of 1 minus 3x, like that, dx. Okay, then from here, the derivative, the integral of hyperbolic cosec squared is cot, but it must be negative. So I have negative 1 over 9 times negative cot of this. So this is negative 1 over 9, negative hyperbolic cot of minus 3x to the power of 3 plus c, which is just 1 over 9 hyperbolic cot of 1 minus 3x cubed plus c. Okay, let's look at number 11. Integral of, yeah.
Isn't it supposed to be positive cot, hyperbolic cot?
What's supposed to be positive?
Yes, because the 9 the cosec is already negative.
Are you saying should my final answer be positive or this cot should be positive?
Yes, because cosec is already negative. It's negative cosec squared, right?
Where is it negative? We're integrating a positive. We're integrating a positive cosec. So my answer.
But it's multiplying with negative 9. Isn't it supposed to be negative cosec squared?
No, this negative is the derivative of that one. So there must be another negative here because this negative comes from this negative there. And here there isn't actually a negative because I have negative times negative, which is positive. So there is no negative.
Miss,
Yeah.
isn't the derivative of normal cosec like minus cot?
The derivative of cosec
squared, isn't it minus cot?
The derivative of cosec squared.
Uh-huh.
You mean
hyperbolic cosec squared, isn't it minus cot?
Yes, it is.
Yeah, that's what it means. Like, isn't it
I have it
supposed
here.
to be
Don't I have
minus
negative?
open bracket?
Listen, you're saying the integral of a normal cot of cosec is negative. That's why try differentiating this one. That's what you should just do. Try differentiating this and see if you get a different answer. And then try yours where you put a negative, I don't know. What are you saying the final answer should be? There should be a negative here or what?
Yes, a negative there.
Okay, let's differentiate this one. The derivative of this is 1 over 9. Derivative of cot negative and then we multiply by the derivative of the inside. Negative and negative will give me positive. 9s cancel, and I have that's my answer when I differentiate this one. And that is exactly what we were integrating. Sorry, there's an x squared here. So I'm not sure what the problem is. Okay, so number 11, we have the integral of sec hyperbolic of sine of x, tan hyperbolic of sine of x over sec of x dx. So you need to remember that if sec of x is in the denominator, you can always bring it up to the numerator, and 1 over sec of x is cos of x. So what we're actually integrating is this cos of x, hyperbolic sec of sine of x, tan hyperbolic of sine of x dx. Okay, then the inside, the derivative of sine is cos. So I can just go ahead and integrate hyperbolic sec tan hyperbolic, which is negative sec hyperbolic. So this is negative sec hyperbolic of sine cos C. Okay, then yeah.
That's the answer.
Yes.
What steps did you skip again? Because
I did not skip any steps.
which one did you integrate, miss?
This one. And this is the derivative of sine of x. Okay, that was number 11. Number 13, we look at the integral. This one is a definite integral. We have e to the power of x, hyperbolic cos of x dx. So with this one, at first glance, you can see that if I differentiate x, I get 1. So where does this e to the power of x, or what does it have to do with the derivative of this? So this is when you have to remember that hyperbolic cos of x means e to the power of x plus e to, plus e to the power of minus x divided by 2. So you write this in terms of e to the power of something. So we are integrating then e to the power of x, e to the power of x, e to the power of minus x over 2 dx from 2 to 3, e to the power of 2x over 2 and then plus 1 over 2 dx. Okay, and this one we know how to integrate. The integral of e to the power of 2x is e to the power of 2x, or let's do the way we've been doing. The derivative of 2x is 2, so I need a 2 here and then a half outside, or just integrate. It's not that difficult. Okay, so here we will have e to the power of 2x divided by 4. And the integral of a half is a half x. And then we have to evaluate from 2 to 3. Okay, then you substitute your values. This is e to the power of 6 over 4 plus 3 over 2 minus e to the power of 4 over 4 minus 1. Okay, and that you can just type in on your calculator. I got 87.708. And that was number 13. Number 15, you would do it pretty much in the same way, where you must rewrite hyperbolic cos in terms of e to the power of x. So we have number 15. We have the integral of e to the power of x hyperbolic cos of 2x dx. Let me see, this was, let me do number 16 instead. dx. So the idea is the same. The hyperbolic sign, you must rewrite it in terms of e to the power of something. So this is the integral of e to the power of x times e to the power of 3x minus e to the power of minus 3x over 2 dx, which is the integral of e to the power of 4x over 2 minus e to the power of minus 2x over 2 dx. Okay, and we know how to integrate e to the power of a function. E to the power of 4x divided by 2. First we will have e to the power of 4x, then we divide by 4, and that 4 will multiply by this 2, so we'll get 8 in the denominator. Okay, and then here, okay, I see that I wrote number 16 slightly different than the way it is in the book. Is a minus there, but you can work it out with a minus. And then with this one, we would have e to the power of minus e to the power of minus 2x. Then we divide by negative 2x, so the negative and this negative will make positive. Then we have e to the power of minus 2x, and then 2 times 2 in the denominator gives us 4. And then we add our constant of integration. So as usual, you can always very quickly check if what you have got is correct. Just differentiate this and see if you end up back where you started. That's how you know that what you've done is correct. And almost all the time, differentiating is much faster than integration. So it shouldn't take you more than a couple of seconds to check that your answer is in fact correct. So we then have the inverse trig functions, inverse trigonometric and inverse hyperbolic functions. So we can start with our table. We have the integral of f prime of x with the square root of 1 minus f of x squared dx. So here, this is just sine inverse of f of x plus c, or they are the same. It's negative cos inverse of f of x plus c. So either one of these, that's a plus here, either one of these is the correct answer, because if I differentiate this with the negative, this is what I get. If I differentiate this, this is what I get. So they are both the answer to the integral of f prime of x over the square root of 1 minus f of x squared. Usually we prefer the positive answer, but the negative one is also correct. They are the same. Okay, the second one, if we are integrating f prime of x over 1 plus f of x squared. So here you need to remember what we did when we were differentiating arctrig and arc hyperbolic functions. So when we don't have the square root already in your mind, you should think of cot and tan. And since this is plus, this is tan inverse. So this is tan inverse of f prime of x plus c, but it is also the same as cot inverse, negative cot inverse of f of x plus c, because the derivative of cot inverse of x, the only difference between the derivative of cot inverse of f of x and tan inverse of f of x is that the numerator is negative. Okay, so if you introduce a negative there and a negative outside, either of these is the correct answer. Okay, and as usual, we prefer the positive one. Okay, but the other one is also correct. And number 3, we have the integral of f prime of x over the square root of f of x squared plus 1. Okay, so here, if you remember, this is the derivative of hyperbolic sine inverse. So the integral of this, I keep forgetting my dx's, but you should put them there. Okay, so this is hyperbolic sine inverse of f of x plus c. Okay, so here there's no or, because that is the derivative of hyperbolic sine inverse of f of x. So the idea with these derivatives and these integrals is you will always want to, you'll be given something and you want to rewrite it so that you have your derivative in the numerator and in the denominator. Like for this one, you have the square root of that function squared plus 1. So that is always slightly tricky part, but manageable. Basic algebra, I would say. Then we have f prime of x over the square root f of x squared minus 1. So dx, this one is hyperbolic cos inverse of f of x plus c. Number 5, the integral f prime of x over the square root of, no square root here, 1 minus f of x squared dx. This is hyperbolic tan of f of x plus c with the condition that f of x squared is less than 1, but it is almost identical to negative hyperbolic. Don't forget the negative over there. Okay, so the only difference, or when we put cot inverse, is if your function is greater than 1. So we just change that square to greater than 1, but almost always we just take the integral as tan. So we see with number 6, the integral f prime of x, 1 minus f of x squared. So you can see we are integrating the same thing, but saying the answer is different. And that is only when we say the condition that f of x squared is greater than 1. So if there's no condition given, then you can pick whether it's tan or cot. Usually we pick the positive one, which is tan. And number 7, integral f prime of x over f of x square root of f of x squared minus 1 dx. This is sec inverse of f of x plus c, or it is minus cosec inverse of f of x plus c. Okay, because the only difference between the derivative of sec inverse and cosec inverse is the minus, otherwise they look the same. And we know that if the difference between two things that you're integrating is a constant, you can always change it and get a different integral. So 8, integral of f prime of x over f of x square root 1 plus 1 minus f of x squared dx. This is minus sec hyperbolic inverse of f of x plus c and number 9, integral of f prime of x over f of x square root of 1 plus f of x squared dx. This is minus cosec hyperbolic inverse of f of x plus c. Okay, so that is just a summary of all the derivatives that involve our arc trig and arc hyperbolic functions. You can look at some of the examples in your book as well as questions in the exercise, and we will continue on Monday at 11:30.